All right. So I went away and started over because I had the right idea. I knew I had the right idea, but like my modeling was so screwed up that uh, it wasn't working, and this was just a bad way to model it. So in, there's no like new ideas here because I did the exact same thing, but I modeled it differently, in a much more natural way. So what I did is I said there's two different kinds of monkeys. One's a specific monkey, which has a name and a value, um, and uh, I took this from the problem itself. Um, yell a specific number or yell there's a math operation. Okay, and then what I said is there's a specific kind of monkey, name and value. There's also a math op monkey, which has a name, an op, a left name, and a right name. And then I did this thing where to make my life easier, where I will actually keep a link to the uh, left and right. And probably I should just not have used a data class for this and just not done this left name and right name, but I did it. So, and then what I said is monkey, there's two kinds of monkey, specific and math op. And so then what I can do is I can parse the line into a monkey and say either I get a math op monkey or a specific monkey. Um, and then I basically did the same thing, but the code's going to be a lot cleaner because I won't have to deal with all these assertions. I'll do it based on matching the type. And also, I will have direct links to the monkeys um, where um, I won't have to look them up. And the problem was, one problem was that I tried using the or notation, specific or math op. It yelled at me, and I couldn't figure out how to make it work. So I had to put in union with this math op in quotes, which is frustrating. But so I think the post init is exactly the same. I saved the root to make my life easier, and I may not have even needed this lookup. I did the same topological sort, and I basically said go through, find every specific monkey, which is a terminal monkey, and say we can evaluate him immediately. And then as long as my order is missing some monkeys, and now the order is actually going to have the monkeys themselves, um, not the names. So I basically say go through each order. It's got to be a math op because I've taken all the specific ones already. It's got a left name and a right name. Um, and if I find something where both the children have already been sorted, then I do a couple things. One is I assign to these pointers. So I left points to left monkey, right monkey. Um, I and then I order add it to the order and append the name. So it's the same logic as last time. Parsing is the same. I re-implemented this router that I don't think I even used it. So and then instead of this yell whatever, I just did calculate. And so um, I did a default value here just so that I can calculate from the root if I want to, because that's what I want to do some of the time. And now, um, now I can use pattern matching with the monkey types, right? So if I have a specific monkey, then I just return its value. And if I have a math op with an op and a left and right, now I can just call calculate on the left because I have the monkey object already and right, and it's much cleaner. And now I just do the case statement. I think Copilot wrote these. Um, and so that works for part one. Then for part two, I want to find the human value. And again, this is exactly what I was trying to do before. I just did it correctly with better modeling. And so what I do is I start with a path. How do I find the path from the root to the human? I did it in a super inefficient way, but it doesn't matter. And I said basically, always look for the monkey who one of whose children is uh, the last thing on the path. And then if I ever get to where um, it goes to the root, stop, right? So I say, if I find a monkey where the left is left and either the left or the right, append it to my path. And now I'm not even keeping track of which way I'm going because I have the path of monkeys themselves. And so I can just, not names, and so I can just check when I need that, right? So I have a path which starts with human and goes up to root. I just put a placeholder for a target value so it won't yell at me. And now what I do is I say, okay, I have this path, right? Um, and I want to pull off the furthest, closest to the root of the path, okay? And if it is the root, um, then I say if left is path one, which means that um, the path is going down the left, then I know that calculate the right value, and that's what I need to equal. Um, this is wrong. I guess I got lucky. All right, I got lucky that it worked. Um, so I find the target value, and whichever way I'm going towards the human, the other value is the target, right? So I need them to be equal. And uh, if I have the human, which I think is always going to be specific, but I decided to cover my bases, then I basically say the target value here is the target value in DL out, so that's what I'm going to return. And then otherwise, I have a left and a right with some operation, right? And here's where I say if left is on the path, then the child value is on the right, and if right is on the path, then the child value is on the left, and that's what we know, okay? And so now I do the same logic I did before. You know, if it's a plus, the target equals the child plus the child I know plus the new target, which is what I want to figure out. And so I just say, you know, do it in reverse. Same for minus, except for minus I need to know which direction I'm going. This is exactly the same logic I had before, except it didn't work. And now it works. So anyway, I think the reason it didn't work before is because my data modeling was so messy that I just screwed up the details. And so that's a lesson about, and I didn't want to rewrite it, right? Because this was just like, I should not have combined this all into one class. That was the bad part because it just ended up being a disaster. So anyway, the moral of the story is model your data correctly because I didn't, and look what happened to me. All right, that's that.